What's up, guys? So today we're doing a video on the characteristics of radical functions, and we're going to find the domain, the x-intercept, and the y-intercept. So for the domain, I want to think about what that means. So if you look at the graph of a radical function, it looks kind of like this. It's like a quadratic turned sideways, except it's only half of it. This half down here is missing. And so it's going to start somewhere and it's going to go to the right forever. Or maybe it'll go backwards. You could flip it sideways and it might start somewhere and go to the left forever. But the reason why it doesn't go this direction forever, it has some starting point, is because you can't have a negative under the radical. That would give you an imaginary number, and you can't graph imaginary numbers on the real number plane. So it's going to start wherever you would get 0 under the radical, and it will go one direction or the other from there, usually to the right. Could go to the left, but it won't go any further down than that. So in this case, what would I plug in here to get 0? You'd plug in a 3, right? If I plug anything greater than 3, I'm going to get some answer. Like if I plug in a 4, I'm going to get 1. If I plug in a 5, I'm going to get 2, and that's fine. These are all things that I can graph. If I plug in something less than 3, say I plug in a 2, I'm going to get a -1, and I can't have the square root of a negative. So that means x has to be 3, which that's what makes it 0, or greater. Okay, so for the domain, I'm going to say x has to be greater than or equal to 3. I can plug in a 3, I get 0, that'd be fine. I can plug in anything bigger than 3 and get some real numbers, so that's fine also. Okay. For the x-intercept, always with, and you've probably heard me say this before, but for any function, if you want to find the x-intercept or the y-intercept, you plug in 0 for the other variable. So if I want the x-intercept, I'm going to plug in 0 for y, meaning I'm going to make this whole thing here 0. And now we just have an easy radical equation to solve. Square both sides, well, that's still 0. Add 3 to both sides. So the x-intercept is x equals 3. I'm going to put it up here. Okay, next we need to find the y-intercept. So for the y-intercept, I'm just going to make x equal 0. Okay, so I'm going to say f of x equals 0 minus 3. Okay, well, 0 minus 3 is -3. And I can't take the square root of -3. I get an imaginary answer. Since we're dealing with real numbers here on the real number plane, I have to say there is none. There is no y-intercept. This graph will never cross the y-axis. Now, if you think about the graph, it's going to actually look like this. We said it has an x-intercept at 3, which is like right here, and it's going to go to the right from there. So you can see why this would never actually cross the y-axis. It's not going to go that far to the left. All right, so now we have another example, slightly more complicated. And so first of all, we're going to find the domain. So remember, the domain is whatever would make the part underneath the radical equal 0. And that's going to be -4. And it's going to go to the right. And by the way, the only thing that would make this go to the left is if the x itself were negative. Remember, making x negative with any kind of graph, you should remember this from your 9th grade transformations in 10th grade. Negative on the x itself flips the graph sideways. Negative outside the leading coefficient flips the graph down. So as long as this is positive, we're always going to the right. So it's going to start at -4 and go to the right. So x must be greater than or equal to -4. The x-intercept, I'm going to write out y-intercept. The x-intercept, I'm going to plug in 0 for the other variable. So I'm plugging in a 0 for y. So I'm going to say 0 equals, so the x-int, 2 times radical x plus 4 plus 6. So I'm going to subtract 6 from both sides. Divide by 2 on both sides. Square both sides. +9. And subtract 4. That's going to give me x equals 5. So the x-intercept is x equals 5. Really, we should be saying 5, 0. If you say 5, that's fine. I think in the other one I said equals. We really should write it as a point, 5, 0. If you just say 5, I'll take it. Okay, the y-intercept. Okay, so for the y-intercept, I got to plug in 0 for the other variable, which is x in this case. So I'm going to say f of x, or let's just say y equals, plug in the 0 for the x. Let's just work this out. That's just 4, and what's the square root of 4? 2, so that's 2 times 2 plus 6. That's 4 plus 6, which is 10. So we have a y-intercept this time. It's 10. If you just say 10, that's okay, but I like to write as a point, 0, 10. Okay, intercepts should be written as points because we're referring to a point on the graph when we say intercept. Okay, and one last example. This time we're looking at a cube root. Okay, but it's largely going to work the same way. So for the domain, now this is one place where it's going to be pretty different. If you think about a cube root, because that's an odd root, there's nothing you can plug in for x that's going to make it not work. There's nothing you can plug in that won't give you some kind of answer back. You can take the cube root of anything you want. So it's only the even roots to give you that problem. So the domain is actually going to be all real numbers. Okay? Unless you, of course, you remember the symbol I like to use for all real numbers. X-intercept, y-intercept. X-intercept means I got to plug in 0 for the other variables. So for y, and then we solve this by adding 3 to both sides. Now I need to cube both sides. So remember, that's not 3 times 3. That's 3 to the third power. So that's 27. And subtract 2 from both sides. So x equals 25. I'm going to say it's the point 25, 0. Okay, and then the y-intercept. Okay, I'm going to plug in 0 for x this time. Okay, so to work this out, I need to take the third root of 2. Now, the third root of 2, you'll notice on your homework it says to round answers to the nearest tenth, and this is the kind of situation where that comes in. So I'm going to use my calculator. I'm going to take the the third root of 2. And that comes out to about 1.26. So if I round that to the nearest tenth, it's going to be 1.3. Okay, so I've got 1.3 minus 3, okay? And that's going to be, if I do 1.3 minus 3, that's going to be negative 1.7. So the y-intercept is 0, negative 1.7. You're going to have decimals on some of your problems. They said to round it to the nearest tenth. That means they don't want radicals in the answer. You need to go ahead and take the root, if it's a cube root or a square root, round it to the nearest tenth, and then continue to work the problem out.